This video is on section 2.2 notes, metric units and metric conversions. So the first thing we need to know about the metric system, which is the system that the whole world uses except for the United States, is that the basic unit of length in the metric system is the meter. So if you look over here, you can see here's kind of the comparison basically between the US and metric. We've got 1 foot, 2 feet, 3 feet is 1 yard, and 1 meter is very similar to a yard. So that's kind of, if you want to know how they compare, that's basically how they compare. Now, the nice thing about meters for length and grams for weight and liters for volume and all of the metric units is that they go by tens. The differences in the prefixes that they use go by tens. They're broken up into tens. And this is different than the US units of measurement, because in the US we have a foot is broken up into 12 inches. We have that a gallon is broken up into 128 ounces. So things are not broken up into tens. They're broken up into all sorts of different numbers depending on the unit of measurement you have. But with the metric system, they're all the same. So a meter is broken up into 10 decimeters, which we don't usually talk about. But we do talk about breaking up a meter into 100 centimeters. So there's 10 centimeters in each decimeter and then 10 decimeters in each meter. Or 100 centimeters in each meter. And then there's 10 millimeters in each centimeter, and then 1,000 millimeters in each meter. So for each of these, you can just learn what the different prefixes mean and how they're related. This is 1 power of 10, 2 powers of 10 for 100, 3 powers of 10 for 1,000. And if you can memorize those, then you can do the conversions, and you can really do them in your head, and you can do them by multiplying by powers of 10, which means you can do it just by moving the decimal place. So this is significantly easier than the work that we did in section 2.1, where we had to know the different conversions for every single different type of unit. Here we're going to be able to use this table and just move decimals back and forth. But before we do that, we're just going to do a little bit of a comparison to the units of measurement that we are used to, like height in feet and inches, and think about it in terms of meters. So if you think about your height in terms of feet and inches, you are probably less than 6 feet, or maybe 6 feet, maybe a little bit more than 6 feet, but somewhere near 6 feet, which means that in meters, 6 feet would be 2 meters-ish, less than 2, maybe 1.5 meters. That's probably about where your height is, somewhere between 1.5 and 2 meters tall. I'm going to go ahead and write down 1.75 meters. The length of a ping pong table may not feel as familiar to you depending on how long it's been since you've seen a ping pong table, if you've ever seen one in real life and not just people playing back and forth maybe in the Olympics or whatever. But a ping pong table is about 3 yards, 9 feet, something like that, about 3 meters maybe. And then the length of a football field, I always think of 100 yards for the length of a football field. So 100 meters, a little bit less than that since a meter is a little bit longer. So maybe like 95 meters or 90 meters or something like that. Here we have some common examples of the different metric prefixes and places that you might have heard them before, and then it shows just the different powers of 10 that have been used in those prefixes. But we'll go ahead and do some conversions so you can see how you can move the decimal back and forth, but we're also going to compare it with our unity fractions so we can see how that would work as well. So first we have 348 centimeters, and we're going to convert that into meters. So 348 centimeters is right here. To convert it to meters, we have to go backwards twice. So we have to go back 1 power of 10, go back 2 powers of 10. And it says anytime you go backwards, you have to move the decimal to the left. And you move it to the left however many spaces you went. So from centimeters to meters, we go back 1, 2 spaces. So I'm going to take my decimal, and in a whole number, the decimal's right here at the end, and I'm just going to move it back twice. So 1, 2, 3.48 meters is the same as 348 centimeters. 7 centimeters to millimeters, we'd take 7 centimeters to millimeters, goes from here to here, so we're going up a power of 10. If you move the decimal to the right or you go to a box to the right, you're going to move the decimal however many spots. So we went 1 box to the right, so we're going to move our decimal 1 place to the right. This is the whole number 7. So if I move it 1 place to the right, then I'm going to have 70 millimeters. I can also do this by using unity fractions. So here if I had 307 meters and I wanted to convert that into kilometers, then I can use my little conversion table. Meters into kilometers. 1 kilometer is 1,000 meters. And so I could say I need to multiply by my unity fraction. I'm going to get rid of the meters. I'm going to introduce the kilometers. And I know that 1,000 meters is the same as 1 kilometer. And so I'll cancel out the meters. And then I'll do 307 divided by 1,000. And get 0.307. And as you can see, if we were to have done this with the table up here, meter to kilometer, we would go back 1, 2, 3 spaces. So our decimal would move to the left, 1, 2, 3 spaces. If our decimal was right here after the 7, you'd move it back 1, 2, 3, which is 0.307. So we can do the unity fractions here, but it's a little bit easier to just move the decimal around. And so we're going to typically do that using this table unless we have to do unity fractions. So 20.5 millimeters to centimeters. For millimeters to centimeters, you go back 1 space. So 20.5, I'm going to take the decimal and move it back 1 space. 2.05 centimeters. All right, on the next page, we are converting different metric units of weight that we have. And so this says milligrams to grams, and I didn't print the chart on this page, so I'm going to have to use it on my conversion table up here. So milligrams to grams. Milligrams to grams, I'm going to go 1, 2, 3 spaces. So 4.5 grams. Kilograms to milligrams, so kilograms all the way over here, so I'm going to go 1, 2, 3, 4, 5, 6. So 6200 milligrams. Milligrams to kilograms, we're going backwards. 1, 2, 3, 4, 5, 6. And kilograms to grams. 1, 2, 3. All right, the next one says to convert our units of volume in liquids, and then we're going to make sure that we round to the appropriate number of significant digits. So I'm going to keep in mind how many significant digits I have in the original number that I'm working with, and then I'm going to make sure that whatever answer I get, I round to that many significant digits. So I have 0.25 liters, and I'm going to convert that into cubic centimeters. So I'm looking for liquid. And I'm not using this table up here because it's liters, and then it's not something that has a prefix with liters. It was cubic centimeters, and that's totally different. So I'm going to have to use one of these down here. So liters and cubic centimeters. Cubic centimeters. Helps if you're looking at the right part of the page. Okay. 1 liter is 1,000 cubic centimeters. So I'm going to put liter on the bottom so it can cancel out, and then cubic centimeters on the top. 1 liter is 1,000 cubic centimeters. And so the liters are going to cancel out, and then I'm going to multiply these together. So 250 cubic centimeters, and when I look at the original number, it was 0.25, and when we have decimal numbers, we do not look at the 0 in the front as a significant digit. So this only had 2 significant digits. I look over here, when I have a whole number, the 0 on the end is not significant, so this only has 2 significant digits, and so I rounded and didn't really need to round, but my number had the same number of significant digits, and so my answer is good. All right, next one, milliliters to liters. This one, I can use this. So milliliters to liters, I'm going to take my decimal and move it 3 places backwards. Milliliters to liters. 1, 2, 3. 5.78 liters. And here, if I look at my original number, it was a whole number, and so the 0 on the end is not significant. So this had 3 significant digits, and my answer has 3 significant digits. I'll try this one. We've got milliliters and microliters, and I've got milliliters on here, but I don't have microliters, and so I'm going to look and see if I've got milliliters compared to microliters, and I do, but you wouldn't necessarily recognize that symbol. So this is microliters. It'll be good to have that written in there. Okay, milliliters to microliters is 1 to 1,000. Okay, so we're going to do 0.45 milliliters. And I want to cancel out the milliliters, and I want to introduce microliters, which is kind of a U shape, but it's like a cursive U almost. This is a mu in Greek. So microliters, and it's 1,000. Okay, so 1 milliliter to 1,000 microliters. We're going to multiply. $450 microliters. Again, we had 2 significant digits in our original number, and so we have 2 significant digits in our answer. And then here we have 80,000 microliters, and we're converting to liters. And if I remember correctly, we're going to have to do 2 conversions because I think the microliters only went to milliliters. Yeah. Microliters only go to milliliters, and so then we'll have to go from milliliters to liters after that. So we're going to go from microliters to milliliters, and it was 1,000 microliters to 1 milliliter. And then from there, we can go from milliliters to liters. So I know that the milliliters is going to be on the bottom so that it will cancel, and liters on the top because I'm introducing liters. So we've got 1,000 milliliters and 1 liter. All right, so the microliters cancel, the milliliters cancel. My answer is going to be in terms of liters. I need to do 80,000 divided by 1,000, and then divide by 1,000 again, 0.08 liters. Okay, and if I look at the original number, it's a whole number with a bunch of zeros after it, and so the only significant digit is the first number, and so my answer can only have one significant digit, and this, whenever you have a decimal number, the zeros in the front are not significant. So the 8 is the only significant number there, so 0.08 is a good answer. Okay. The next section, we're going to convert speed units, and we're doing significant digits again. So we have 100 kilometers per hour, and we're converting to meters per second. So first I'll do the 100 kilometers. I can convert that to meters per hour pretty easily. So kilometers converted to meters. Kilometers converted to meters, we're going to go 1, 2, 3 decimal places to the right. So 100, I didn't leave myself very much room, so there's the decimal place. 1, 2, 3 decimal places to the right, and I'll fill in the zeros. So that's 100,000 meters per 1 hour. And then I want to do meters per second. And so I need to get rid of the hours units and introduce seconds units. So I'll get rid of the hours by putting hours on the opposite side, and then I'm going to introduce seconds. And these time units are on the other side of the page. We used these on the previous section. 1 hour is 3,600 seconds. Okay, so I'm going to do 100,000 divided by 3,600. Okay, 27.7777. Meters per second. Okay. And if I look at the original problem, this original problem only had one significant digit, 1 and then 2 zeros, and with a whole number, we don't look at those zeros as significant. And so if I was to write this as a number that had one significant digit, I would have to write this as 30. So 30, that way it has one significant digit. It's a 2-digit number, but only one of them is significant. So 30 meters per second, if I'm rounding to the appropriate number of significant digits. And then over here, we're converting from centimeters to meters. And centimeters to meters, I'm going to move the decimal places 2 to the left. So 2 to the left would be 13.6 meters per second. And then we need it to be meters per minute. So I need to convert now from the seconds into minutes. So I'm going to put seconds up here so that the seconds will cancel out. And I'll put minutes down here to introduce minutes into the problem. So I have 60 seconds for 1 minute. And I knew that off the top of my head, but it's also on the sheet. So 60 seconds for 1 minute. And then I'll do this multiplication. So 13.6 times 60. 816. Meters per minute. And when I look back at the original problem, this is a 4-digit number. It's a whole number. There's a 0 on the end, and that's not a significant digit. So there's 3 significant digits in this number and 3 significant digits in my answer. All right. The next problem says, if a patient takes 60 milligrams of a medication 3 times a day, how many grams will the patient take in 4 days? So first we can see how much medication that patient takes in 1 day. So 60 milligrams 3 times a day. 60 milligrams 3 times a day is 180 milligrams per day. And it says that they did this for 4 days. So 180 milligrams per day for 4 days. 720 milligrams in 4 days. And then the question is, how many grams did the patient have? And so we're going from milligrams to grams. And so I'm moving the decimal place 1, 2, 3 places backwards. So I'll start right there. 1, 2, 3 places backwards. So 0.72 grams of the medication over the course of 4 days. Okay. All right, the next example says the length of a steel component is given as 8.6 centimeters. What is the greatest possible error of this measurement in millimeters? And they tell us that the greatest possible error is half of the precision, or half of 0.1 centimeters, which is 0.05 centimeters. So the precision of this problem is 0.1. Because this number is to 1 decimal place. So the precision is 0.1 or 1/10, because this number is to the nearest 1/10. It's 8.6, but other tenths could be like 8.5, 8.7, so they rounded this value to the nearest tenth, and so that's the precision that it has. It has precision to the nearest tenth, and so the greatest possible error is half of that. So 1/10 divided in half would be 1/20th, which as a decimal is 0.05. So if we're going to write down how far off you can be from that measurement, you would say that you can be off 8.6 centimeters plus or minus 0.05 centimeters. So you can be 0.05 centimeters too big or 0.05 centimeters too small. That's how big or how small you could be past the 8.6, which would be kind of like the perfect measurement. Now they're asking you to write this in millimeters, and so if we look at this, to go from centimeters to millimeters, we just have to take our decimal place and move it to the right 1 spot. So we're going to say that we have 86 millimeters plus or minus 0.5 millimeters. And so our greatest possible error in millimeters is 0.5 millimeters. So this problem didn't require a lot of math. You really had to read and understand what the problem was asking. All right, the cruising speed of a Boeing 787 is Mach 0.85, which means that 0.85 times the speed of sound. So there's the speed of sound, and then a little bit less than that is how fast a Boeing 787 is. So it says if the speed of sound at cruising altitude is 295 meters per second, what is the cruising speed of that airplane? If we put it in kilometers per hour. So we're going to take the cruising speed of the airplane and we'll convert it into kilometers per hour, but then we need to make sure that we take this speed of sound and multiply it by 0.85 so that we can actually get it for the airplane and not just the speed of sound. So 295 meters per second is what we have for the speed of sound, and we know that the airplane is supposed to be 0.85 of that. So 0.85 times whatever we get for this when we finish this conversion. So meters converted to kilometers. Meters converted to kilometers. I'm going to move the decimal 1, 2, 3 spaces to the left. So 0.295. So that's 0.295 kilometers per second. Okay. And I'm going to convert this seconds into hours. So I want to get rid of the seconds, put seconds on top. I want to introduce hours, so I'll put hours on bottom. And I know that 1 hour is 3,600 seconds. 1 hour is 3,600 seconds. Okay. So 0.295 times 3,600. So what we have just done is we have taken the speed of sound, and we took it from 295 meters per second and we converted it into 1,062 kilometers per hour. And now we need to say, well, the Boeing 787 is 0.85 times the speed of sound. So we need to take this number and multiply it by 0.85. 902.7. Kilometers per hour. And they didn't tell us how to round this, and so we can leave it as 902.7 kilometers per hour. We could round it to the nearest whole number, 903 kilometers per hour. Either one of those is fine. All right. And then our last example says, in working with intravenous infusion, IV, nurses often measure flow rates in drops or microdrops per minute, while the solution itself is measured in milliliters. Suppose that a 750 milliliter IV must be given to a patient over a period of 6 hours, and the nurse must set the flow rate in drops per minute. So we have milliliters per 6 hours. I'm going to write that down to start. 750 milliliters per 6 hours. Okay. But we know that the nurse is going to have to do drops per minute. If the drop factor for this solution is 15 drops per milliliter, what flow rate should the nurse set? So the goal at the end of this problem is to have drops per minute. So I need to get rid of the milliliters. I need to introduce drops. I need to get rid of hours. And I need to introduce minutes. So 15 drops per milliliter is the conversion that is not on my table because it's just specific to this problem. So 15 drops equals 1 milliliter. So I'm going to get rid of the milliliters and I'm going to compare it with the drops. I'm introducing drops in the problem. I'm getting rid of milliliters in the problem. So 1 milliliter per 15 drops. And then the flow rate we want to have is drops per minute. That's what we want at the very end of the problem. And right now we have drops per hour. So now I need to convert from hours into minutes. So I'm going to put hour on top because I need these hours to cancel. And then I'm going to put minute on bottom. And so hours and minutes, 1 hour is 60 minutes. And so if the hours cancel, I'm going to end up with drops per minute, which is what a nurse would have to set this to. Okay, so 750 times 15 divided by 6 divided by 60. It's 31.25. And it says to round to the nearest whole number. So 31.25 would round to 31, and that is drops per minute.